What is time? It's this fundamental, elusive mystery, isn't it? You can't hold it, you can't really see it, but you feel its passage constantly. Sometimes, well, like the sources put it, like it's just slipping away.
It's this universal experience connecting everyone, everywhere, across all ages.
And because time is so central to our existence, humanity has, from its very beginnings, been engaged in this relentless quest regarding it.
Yeah, it's more than just watching it pass. It's this attempt to grasp it, to measure it, and, in some ways, maybe even to control this intangible force.
Absolutely. And the sources you've provided, they take us on this incredible journey, starting from the simplest tools imaginable, maybe just a stick in the sand, a gnomon.
Right, all the way to the incredibly sophisticated and visible pulse of atoms ticking away in our most modern clocks today.
It's a story that spans thousands of years, a true deep dive into history, science, philosophy even. Our mission today is really to unpack these sources and trace this extraordinary evolution.
From those ancient people looking up, watching the stars and sun, to the state-of-the-art atomic clocks that, well, pretty much govern so much of our modern world.
And along the way, we'll see how the very concept of time has undergone these profound transformations.
It really has. It started deeply rooted in myth, tied to cosmic rhythms, something observed in nature, often linked to divine power or, natural cycles.
Then it shifted dramatically towards precise quantitative measurement, becoming a tool for organizing human activity, society itself.
And in our current era, the sources note its manifestation as almost, well, they call it capitalist precision, where time is rigorously scheduled, tracked, valued as this key metric of productivity and control.
So this isn't just a simple history of clocks and calendars, is it?
Not at all. It's a narrative that's fundamental to the story of civilization itself. The methods, the precision with which we've measured time, they've directly influenced how societies have been structured.
How people have lived their daily lives, how our world operates on a global scale. It's huge.
Definitely. So let's open up these sources and dive into the fascinating details they offer on this complex and evolving relationship humanity has with time.
Okay, let's start right at the beginning with that foundational question the sources pose. What is time? It's described poetically as the invisible thread connecting the past, present, and future.
It feels simple, doesn't it? Yet defining it precisely has challenged thinkers for millennia.
Absolutely. Thinkers from all sorts of disciplines have wrestled with this. Philosophers, for instance, they've long debated its fundamental nature.
Is time a real objective dimension of the universe? Something that exists independently of us? Or is it primarily a construct of the human mind, a way we organize our experiences of change in sequence?
Big, abstract questions,
Yep.
but they frame the different ways we've tried to pin time down.
And then scientists stepped in, adding their own perspectives. For a very long time, the view that really dominated was from Isaac Newton.
Right, his physics described a universe where time was absolute, unchanging.
Yes, Newton conceived of time as this kind of universal, constant river. He imagined it flowing at a perfectly steady rate, uniformly throughout the entire cosmos, completely independent of space, matter, anything else happening.
So, in his view, everyone everywhere experienced time passing identically.
Exactly. A second here was the exact same second, say, on the moon, flowing at the very same speed.
Which seems intuitive to our everyday experience, doesn't it? A minute feels like a minute, no matter where you are.
It did, and this model of absolute time, it worked remarkably well within Newtonian physics for centuries. It accurately described planetary motion, projectiles, machines.
But then came the 20th century, and Albert Einstein.
And he presented a radically different picture with his theories of relativity. He completely shattered that Newtonian idea of absolute time.
How so?
Well, Einstein showed us that time isn't absolute at all. It's actually intimately woven together with space, creating what we now call space-time. And crucially, time is relative.
Relative, meaning it's not a universal constant.
Precisely. It bends, it stretches, it can pass at different rates depending on things like gravity and motion. For instance, time actually slows down the stronger the gravitational pull.
Seriously, so time passes slower, closer to, say, a massive object.
Yes, and it also slows down for an object the faster it moves relative to an observer.
So two people could experience the same event but measure different amounts of time passing if one was moving faster or was in a stronger gravitational field.
That's exactly it. The passage of time becomes relative to the observer's frame of reference, their location, their speed, their state of motion. It was a truly revolutionary concept.
Mind-bending stuff, really. Okay, so we go from this abstract philosophical debate and complex modern physics back to the very beginning. Early humans.
Long before Newton or Einstein or even abstract thought about time, the earliest humans had a much more immediate practical relationship with it.
It wasn't philosophy for them.
Not at all. For ancient hunter-gatherer societies, understanding and anticipating the rhythms of time wasn't about abstract concepts. It was a direct matter of survival. They needed to know when things happened in the natural world just to stay alive.
Like what sort of things?
Well, think about it. When did the animals they hunted migrate through their territory? When was the safest time to move camp to avoid, say, harsh winter weather?
When did seasonal fruits ripen or nuts become ready?
Exactly. And if they were starting to cultivate plants, when was the right time to sow the seeds? And just as importantly, when was the right time to harvest? Missing those critical windows could mean starvation.
So, knowing the timing of natural events was directly tied to food, shelter, safety. It was just woven into the fabric of their daily and seasonal lives.
Precisely. Their lives were utterly dependent on aligning their activities with the natural cycles of the world around them.
And because this understanding was so critical for survival, where would they naturally look for the most reliable, recurring patterns?
Up to the sky.
Makes sense.
The sky, with its predictable movements and cycles, became humanity's first, most universal clock and calendar.
So let's imagine that early human standing outside looking up. How did they translate those observations into understanding time?
Well, the celestial sphere offered these constant observable markers. The most obvious, of course, was the sun.
Day and night.
Right, its daily arc across the sky rising in the east, setting in the west, that naturally divided the period of light. They could track its highest point as a rough midday marker. That gave them the fundamental rhythm of the day.
And then there's the moon.
Exactly, the phases of the moon. That regular cycle, from a thin crescent to a full disk and back again, provided a natural, visible division of longer periods. That gave rise to early concepts of weeks, or more significantly, months.
The moon cycle is so clear, so visible to everyone, everywhere.
It is. And it was the basis for many of the earliest calendars across different cultures. The sources mention civilizations like the Babylonians, the Chinese, the Jewish people, the Mayans. They all began with calendars that were primarily based on the cycles of the moon.
These lunar calendars, usually 12 lunar months, trying to track the year.
That was the aim. But there's a well-known issue with purely lunar calendars, isn't there? They don't quite match up with the sun.
Yeah, the solar year, the cycle of the seasons.
That's right. A lunar month is about 29 and a half days. 12 of those add up to roughly 354 days. But the time it takes Earth to orbit the sun, the solar year, is about 365 and a quarter days.
So you've got a difference, about 11 days per year.
Exactly. An 11-day gap between a purely lunar calendar and the actual solar year.
And what was the practical consequence of that 11-day difference adding up year after year?
For societies that relied heavily on the seasons, especially for agriculture, this drift was, well, it could be disastrous.
How?
Imagine your calendar says it's time to plant crops based on the moon phase. But because your calendar's been drifting backwards by 11 days every year, the actual season is shifted. You plant at the wrong time.
Leading to potential crop failure.
Exactly. And not just farming. Seasonal religious festivals, important community gatherings tied to harvests or solstices, they'd fall increasingly out of sync with the natural world they were supposed to mark.
So this calendar drift wasn't just an abstract problem. It had real, tangible, negative impacts on their lives. It created confusion, disruption.
Absolutely. So the solution that many cultures developed, often independently, was to create what we call lunisolar calendars.
Lunisolar. So combining moon and sun.
Kind of. They still primarily track the moon for the length of their months because that cycle is so visible. But they found ways to keep those lunar months roughly aligned with the solar year and the seasons.
How did they manage that?
The most common method, described in the sources, was by occasionally adding an extra month to the year. An intercalary month, they called it.
So like a leap month instead of a leap day.
Sort of, yeah. This would happen roughly every 2 or 3 years, depending on the specific system. By inserting this extra month, they could pull the calendar back into closer alignment with the solar cycle.
A correction mechanism.
It was. The sources call this process one of humanity's first technological fixes for nature's inconsistencies. It wasn't perfect, but it was a clever adjustment born out of necessity and careful observation.
A technological fix using observation.
Yeah.
Fascinating. Okay, let's move forward geographically and historically to ancient Egypt. The sources say timekeeping there took on another layer of significance.
Ancient Egypt is a wonderful example of how timekeeping wasn't just about farming or daily schedules. It was deeply integrated with their religious beliefs, their whole cosmology. Time had both practical and deeply sacred meaning.
And the priests played a key role.
Yes, the priests in Egypt weren't just keepers of religious texts. They were also keen astronomers, observers of the celestial world. They studied the heavens, tracked the sun's movement meticulously.
And what was their primary tool for tracking time during the day? We mentioned the stick in the sand earlier.
The nomenes. It sounds incredibly simple, just a stick or maybe a larger obelisk planted vertically in the ground, but it was remarkably effective.
How did it work?
As the sun moved across the sky, the gnomon cast a shadow. By observing how the length and the position of that shadow changed throughout the day, they could divide the daylight hours into segments.
And that's basically the birth of the sundial, right?
Precisely. Early sundials evolved directly from the gnomon. By marking divisions on the ground around the base or carving them onto stone structures, they created formal sundials that could visually indicate the passage of time during daylight.
And the Egyptians, the sources note, divided their day into 12 hours.
Yes, 12 hours of daylight and also 12 hours of night.
Why 12? Was that number significant?
The sources suggest it was deeply aligned with their religious symbolism and understanding of the cosmos. Their cosmology involved, for example, the sun god Ra's journey through 12 gates or regions of the underworld during the night.
Ah, so the 12 divisions of the day mirrored the 12 divisions of the night's journey.
Exactly. So dividing time into 12 units for both day and night wasn't just practical measurement. It reinforced their spiritual view of the universe, the cycles of life, death, and rebirth.
Okay, so sundials worked for the 12 hours of daylight, but what about the 12 hours of night? You can't use a sundial in the dark.
That was their challenge indeed. How do you measure time consistently when the sun isn't visible? And their ingenious solution was the water clock, known as a clepsydra.
Clepsydra, water clock, how did they work?
The simplest form involved a vessel, often stone, maybe conical with sloping sides, filled with water. There was a small hole near the bottom. Water would slowly drip out of this hole at a relatively constant rate.
And time was measured.
By the change in the water level inside the vessel, they'd mark calibrated lines on the inside for different hours. As the water dripped out, the level fell past these lines, indicating time's passage.
Why conical, not just a cylinder?
Good question. The conical shape, with sloping sides, helped ensure a more consistent rate of flow as the water pressure decreased when the level dropped. Some later versions collected the dripping water in a second vessel, using the accumulation to mark time.
So time measured by how much water had flowed out or how much the level had fallen, that's incredibly inventive for a time without mechanical parts.
It truly was. And water clocks allowed them to measure time around the clock, day and night. But the Egyptian relationship with time went even beyond these tools.
Right, you said it was about aligning human activities with divine order.
Yes. As the sources emphasized, their view of time was about fitting human life into the divine order they perceived in the celestial and natural world.
You mentioned their priests were astronomers. Was there a specific celestial event tied directly to their survival?
Yes, a crucial example is the star Sirius, Sothis they called it, the brightest star we can see.
In its significance.
The sources detail that its heliacal rising, that's the first time the star becomes visible again in the eastern sky just before sunrise, after being hidden by the sun's glare for a period, coincided almost perfectly with the annual flooding of the Nile River.
And the Nile flood was everything to Egyptian agriculture.
It was the absolute lifeblood of their civilization. The floodwaters brought fertile silt from the highlands, irrigated the land, made farming possible in that desert environment.
So the appearance of Sirius wasn't just an astronomical curiosity.
Not at all. It was a sacred sign, marking the imminent life-giving flood. Knowing when Sirius would rise allowed them to anticipate the flood, prepare the land for planting, time their entire agricultural cycle for survival.
That's a powerful link. Cosmos, divine signs, practical survival.
It really highlights the source's point that for the Egyptians, measuring time, tracking the sun, the stars, the Nile's rhythms was, as they put it, a spiritual duty as much as a practical one, living in harmony with the cycles of creation.
From Egypt's spiritual structure for time, the sources tell us we move to Babylon, where time was given numbers and a mathematical structure. Sounds like a shift in focus.
It is a definite shift. While Babylonian priests were also avid observers of the stars and planets, meticulously tracking their movements and cycles, believing these patterns held keys to understanding both the cosmos and earthly events.
They also saw divine meaning in the stars.
Yes, very much so. But their unique and lasting contribution was mathematical. They were pioneers in applying sophisticated mathematics to astronomy and timekeeping.
And what was their brilliant mathematical innovation?
Their standout contribution was their development and extensive use of a base 60 number system. Sexagesimal, it's called.
Base 60. We use base 10. Why 60?
It seems complex to us, but it had significant advantages, especially for calculations involving fractions and division. The number 60 is highly composite.
Meaning?
It can be divided easily by a large number of factors. 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60 itself.
Ah, so it's easy to split into halves, thirds, quarters, fifths, sixths.
Exactly. And tenths, twelfths, and so on, and you get whole numbers each time. This makes dividing quantities like circles or periods of time into smaller whole subunits very straightforward and flexible, incredibly useful for astronomical calculations and organizing time.
And the sources give a fascinating possible origin story for this base 60 counting system, using hands.
This is a wonderful detail, showing how ancient practices can influence sophisticated systems. The theory is they use their hands in a specific way. On one hand, you use your thumb to count the 3 segments, or phalanges, on each of your other 4 fingers.
Okay, so 3 segments per finger times 4 fingers. That's 12.
Right, you'd point at each segment, 1, 2, 3 on your index finger, then 4, 5, 6 on the middle, up to 12 on the pinky.
Got it. And then?
Then you use the 5 fingers of your other hand to keep track of how many times you'd counted to 12 using the first hand. 5 fingers, each representing a group of 12.
5 times 12 equals 60. Wow, that's a very physical, tangible way of building up to 60. It grounds this abstract system right in human anatomy.
It does. And the legacy of this Babylonian base 60 system is still directly with us today, thousands of years later. It's quite amazing.
How so?
We divide our hours into 60 minutes and our minutes into 60 seconds. The geometry of circles is based on 360 degrees, which is 6 times 60. That's pure Babylonian influence, carrying through history into our modern units of time and angle.
That's incredible. Are digital watches ticking based on a counting method possibly derived from ancient hands? Did the Babylonians also struggle with that calendar drift problem we talked about earlier?
Yes, they were sophisticated observers. They certainly recognized the drift in purely lunar calendars relative to the seasons. Like other cultures developing lunisolar systems, they needed a way to periodically bring their calendar back into alignment.
And their method was?
Similar to others,
Yeah.
they would add an extra intercalary month to the year when their astronomical observations showed the calendar was getting too far out of sync with the seasons.
So it wasn't a fixed rule like our leap year, but more of an observational adjustment based on need.
Precisely. The sources characterize this as a primitive but brilliant form of calendar engineering. It required continuous observation and a decision, likely by the priests, based on those observations, to insert the extra month, keeping their calendar in step with agriculture and natural cycles.
So for the Babylonians, time was structured by their advanced math based on meticulous astronomical observation. A sacred balance, maybe, between the stars and society needing constant tuning.
A powerful combination of mathematical logic and celestial observation. Now, moving from that sacred mathematical balance, the sources take us to Rome and introduce a distinctly different relationship with time. They characterize it as being weaponized.
Weaponized? That sounds pretty dramatic. How did Rome weaponize time?
Well, the sources highlight the state of early Roman calendars as the starting point. They were, frankly, a chaotic mess.
A mess how?
Initially, they were said to have only 10 months. They completely omitted the winter period.
Just pretended winter didn't exist on the calendar. That's bold.
A seemingly impractical approach. They later added 2 months, January and February, probably at the beginning of the year, bringing the total to 12. But even with 12 months, the calendar wasn't perfectly aligned with the solar year. It was still based on complex, somewhat arbitrary rules for inserting extra days or months.
Making it irregular and prone to drifting from the seasons.
Exactly. And who was in charge of managing this messy calendar? The priests. The pontifices.
And because the system was complex and allowed for flexibility?
The sources describe how the pontifices began to exploit this control for political purposes.
So they literally manipulated the calendar for political gain. How did that work? Give me an example.
Exactly. They could lengthen or shorten the year or specific months by adding or removing days. The sources give the specific example of delaying a senator who is scheduled to appear in court for a trial,
Wow.
simply by adding extra days to the current month, pushing the trial date back conveniently. Or they could lengthen the term of a favored official by extending the year, or shorten the term of a political opponent.
That's incredible. Imagine having the power to literally control the clock to suit your political agenda. That must have caused massive confusion.
It absolutely did. The calendar became unpredictable, subject to manipulation. It led to widespread confusion about dates, seasons. This chaos was a huge problem for practical matters agriculture, coordinating military campaigns.
I can see that. Imagine campaigns starting late because the calendar was 3 weeks off.
Right, and collecting taxes, administering the vast Roman Republic. It was becoming untenable.
And this chaos is what led to Julius Caesar stepping in.
Yes, by 46 BCE, the situation was a disaster. The Roman calendar was estimated to be about 3 months out of sync with the actual seasons.
3 months?
Yeah. Julius Caesar, consolidating his power, recognized that a stable, reliable calendar was essential for the effective administration of the Republic and the future empire. He wasn't going to tolerate this weaponization of time anymore.
And he brought in an expert, didn't he?
He did. To fix the calendar, he enlisted Sosigenes of Alexandria, an Egyptian astronomer. Sosigenes had a deep understanding of the solar year, likely drawing on generations of Egyptian observation refined with Greek mathematics. Together, they devised a new system,
Which became the Julian calendar.
the Julian calendar, a monumental reform. It was designed to be a purely solar calendar, moving away from the complexities and drift of lunar or lunisolar systems.
How did it work?
It fixed the length of the year at 365 days, much closer to the true solar year. And it introduced a simple, predictable rule to account for the extra quarter day, a leap year, adding an extra day every 4 years.
February 29th.
That's the one. This brought incredible stability.
I bet.
It was revolutionary. The Julian calendar provided much-needed predictability, consistency. It stabilized the relationship between the calendar date and the seasons, ensuring farming could be planned reliably. It also provided a standardized framework for administration across Roman territories.
So it helped unify the empire in a way.
Absolutely. Facilitating everything from tax collection to military movements. It became the standard across the Roman world and later in Europe for a very, very long time.
Over 1,500 years, right. It was a huge improvement.
A vast improvement. However, as the sources point out, it wasn't perfect in its alignment with the true solar year. It had a small but cumulative error.
What was the error?
The Julian year of 365.25 days is just slightly longer than the actual average length of the tropical solar year, which is about 365.2422 days.
Okay, so the difference is tiny. How much?
About 11 minutes and 14 seconds per year. Seems negligible, right?
Just 11 minutes a year feels tiny.
It does. But over centuries, that tiny error adds up. That cumulative drift meant the calendar date was slowly getting ahead of the actual astronomical events like the equinoxes and solstices.
So spring was arriving earlier, according to the calendar, than it actually was.
Exactly. And by the late 16th century, specifically by 1582, that 11-minute-a-year error had accumulated to about 10 full days.
10 days, and that caused problems.
It did, particularly for the Christian church. The date of Easter is calculated based on the vernal equinox, the start of spring. This drift was causing Easter to move further and further away from its intended place in the spring season.
Okay, so the religious calendar was getting messed up, and this is where Pope Gregory III comes in.
Exactly. Recognizing the growing problem, especially for dating Easter correctly, Pope Gregory III commissioned astronomers and mathematicians to develop a new, more accurate calendar system. This resulted in the introduction of the Gregorian calendar in October 1582.
And how did the Gregorian calendar fix the Julian drift? What was the tweak?
It made a subtle but crucial adjustment to the leap year rule. Instead of every fourth year being a leap year, like the Julian system,
Yes.
the Gregorian calendar keeps the leap year every 4 years, except for century years, unless that century year is divisible by 400.
Okay, hang on. So years like 1700, 1800, 1900, they were not leap years.
Correct, even though they're divisible by 4.
Yeah.
But the year 2000 was a leap year because it's divisible by 400.
Ah, okay. That's the refinement, dropping 3 leap days every 400 years.
Precisely. This slight adjustment brings the average length of the calendar year much, much closer to the true solar year, reducing the drift dramatically. The Gregorian calendar is the one most of the world uses today, and it's remarkably accurate.
So a refinement of Caesar's solar system for even greater accuracy.
Okay.
From the political world of Rome and these calendar systems, the sources take us to a very different setting for timekeeping, the Middle Ages.
Yes, after the decline of the Roman Empire, especially in Europe, the structure of timekeeping shifted again. The church, and particularly the monasteries, became the new central figures in organizing and marking time.
How did that happen? What was the focus?
Well, life in a monastery was incredibly disciplined. It was structured around a rigorous schedule of prayer and work. Monks were required to pray 8 specific times throughout the day and night at set hours. These were the divine offices or canonical hours.
8 times a day, like clockwork.
The source uses that exact phrase, like clockwork, even before widespread mechanical clocks existed. These fixed prayer times provided the framework for their entire day, their entire community life.
But how do they know exactly when those 8 prayer times were? Without personal watches or perfect sundials everywhere.
That was the challenge. Initially, they relied on simpler tools we've already mentioned. Water clocks, the clepsydras were used, though they could be fiddly, unreliable, needed constant attention.
And other methods.
They also used things like calibrated candles. Candles marked with lines, where the passage of time was measured by how much wax had burned down. But these weren't ideal for signaling time across a whole community, were they?
No, you need something loud. Which brings us to bells.
Exactly. A powerful and effective tool emerged. Large bells installed in monastery towers. Monks would ring these bells at the scheduled times for each of the 8 prayer services: matins, lauds, prime, terce, sext, none, vespers, compline.
And the sound carried.
Oh, yes. It carried throughout the monastery and, crucially, out into the surrounding areas, the villages, the fields.
So the bells weren't just an internal signal for the monks. They were broadcasting the time to the wider community.
That's the key transition here. As towns and villages grew up around monasteries, or as local churches built their own bell towers, the ringing of the bells became the primary public time signal for everyone within earshot.
So the bells told everyone, okay, it's time for...
Pretty much. They told farmers when to start work or take a break, merchants when to open or close their stalls, craftsmen when to start their day. They signaled community gatherings, church services, the general rhythm of the day from dawn till dusk and beyond.
So time was no longer just celestial or private like a water clock.
It became audible, public, shared, communal.
The sources call it a social heartbeat.
It's a great description. The ringing of the bells provided this shared beat that organized the lives of everyone in the community, fostering a sense of shared temporal experience long before personal clocks were common.
A town living by the beat of the bells. That's a vivid image. This leads us nicely into what the sources describe as the silent revolution, the arrival of mechanical time.
This marks another fundamental shift, starting around the 14th century. This is when true mechanical clocks started to emerge.
And these were different beasts altogether.
Oh, yes. Complex machines, feats of early engineering, intricate gear trains, powered usually by descending weights, and regulated by something called an escapement mechanism.
An escapement? What's that?
That's the clever bit. It controls the release of energy from the weights in regular discrete steps, making the gears turn at a steady, measurable rate. It's what makes the tick-tock sound in older clocks.
So a system driven by weights and gears, not sun, water, or candles. What was the main advantage?
Reliability and independence from natural elements. They could mark the hours accurately, 247, in any weather, day or night, without needing constant supervision like a water clock or sunlight or a candle burning just right. Consistent, continuous measurement.
And like the early bells, where did these first mechanical clocks appear? Were they personal items?
No, not at first. The earliest ones were large, incredibly expensive, very complex to build and maintain. So they were initially installed in prominent public spaces high in the towers of cathedrals, abbeys, and later town halls, often driving large dials and sometimes striking bells automatically.
So the beat of time became visible too?
Exactly. The sources note that the beat of time, represented physically by the ticking mechanism inside and visually by the hands moving on a public dial, was no longer hidden away or just a sound. It became visibly present in the town square, a constant mechanical presence.
Making time's passage more concrete, maybe. And a famous scientific mind made a key contribution to improving these clocks.
Indeed. Galileo Galilei. In 1583, the story goes, he was in the Cathedral of Pisa and made a crucial observation.
What did he see?
He watched a lamp, a chandelier maybe, swinging back and forth on a long chain, and he noticed something remarkable, apparently timing it against his own pulse.
Which is...
Regardless of how wide the swing was, whether it was swinging far or just a little, the time it took for the pendulum to complete one full back and forth swing seemed to remain constant. It swung with what he described as perfect regularity.
Ah, the isochronism of the pendulum. That immediately suggested using a pendulum to regulate a clock, didn't it?
It did. Galileo realized a pendulum could provide a much more stable and accurate rhythm, a much better time base, than the earlier, cruder escapement mechanisms like the verge escapement used in the first tower clocks.
Did he build one?
He conceived the idea, made sketches, but apparently never built a fully working model. It was the brilliant Dutch scientist Christian Huygens who, in the mid-17th century, successfully designed and built the first practical and accurate pendulum clock, translating Galileo's observation into a working revolutionary device.
And the pendulum clock massively increased accuracy.
It was a huge leap in precision. Pendulum clocks were far more accurate than anything before. This enabled significant advances in science astronomy, physics experiments, things that needed really precise timing, and it also spurred advances in navigation, the search for longitude at sea.
And as the technology improved, clocks got smaller,
Yes, as mechanical clock technology advanced, became more refined, it also became more miniaturized and eventually more accessible.
leading to personal timekeeping.
Exactly. By the late 17th century and definitely into the 18th, smaller mechanical clocks for the home and then portable pocket watches became increasingly fashionable, especially among the wealthy and educated classes.
So timekeeping was no longer just public or monastic. It was something you could carry with you.
A personal measure of time, right there in your pocket. A status symbol, too, initially.
And the public signals of time kept evolving as well. You mentioned bells earlier.
They did, particularly with the Industrial Revolution of the 19th century. As huge numbers of people moved into towns and cities to work in factories, the rhythm of life shifted dramatically.
From natural cycles or church bells to...
The demands of industrial production, factory whistles blaring out signals for the start and end of work shifts, for lunch breaks, for shift changes, these began to replace or at least supplement church bells as the dominant public time signal in industrial towns. Time was now dictated by the factory schedule.
So mechanical time brought precision, but also, as the sources put it, control.
That's a key insight. Mechanical time became incredibly precise, increasingly personal, yes, but it also became a powerful tool for control and organization on a massive scale.
How so?
The rise of accurate, standardized mechanical clocks facilitated the standardization of work hours the factory day. It enabled the coordination of complex industrial processes, the scheduling of transportation like trains, which absolutely required accurate, synchronized time.
People didn't just live in time anymore.
They were increasingly expected to live by time, adhering to rigid schedules, deadlines, the clock on the factory wall. Time became a framework for discipline, efficiency, productivity in this emerging industrial world.
The silent revolution wasn't just about the machines. It was about fundamentally reshaping society around a standardized, measured hour.
It completely changed the perception and the experience of time for the average person. It became something that structured and, in many ways, constrained life.
Which brings us to the 20th century and beyond. The era of modern timekeeping, defined by what the sources call a new kind of race.
Yes, a race not for land or gold, but for the ultimate precision in measuring time itself. The 20th century saw incredible leaps.
Starting with quartz.
The first major development was harnessing the properties of quartz crystals, discovered properly in the 1920s.
What's special about quartz? How does it keep time?
Certain materials, quartz being a key one, exhibit the piezoelectric effect. Squeeze them, they produce a tiny electrical voltage. Apply electricity to them.
They vibrate.
Exactly. They vibrate at a specific, incredibly stable frequency when an electric current is applied. Really, really stable.
So you can use that precise vibration
to regulate an electronic circuit. It provides an extremely accurate and consistent heartbeat for timekeeping, much more stable than a mechanical balance wheel. Millions of vibrations per second.
And this led to quartz clocks and watches.
Which completely revolutionized timekeeping for the masses. Quartz clocks were significantly more accurate than most affordable mechanical clocks, and crucially, they could be mass-produced relatively cheaply.
So they powered everything.
Wristwatches, alarm clocks, kitchen timers, wall clocks, and they became essential components in early computers and countless other electronic devices. They brought unprecedented accuracy to ordinary homes and onto ordinary wrists.
Quartz seemed like the final word for a long time. Accurate, cheap, reliable.
This is a huge step forward, definitely democratize accurate time. But as the source notes, even quartz wasn't perfect. For certain highly demanding scientific and technological applications, its accuracy still wasn't quite enough. There was this continuing drive for even greater precision.
The world demanded better.
That's the phrase. And that demand for the ultimate precision led to the development of the atomic clock.
The atomic clock, which the sources call humanity's most precise tool. How precise are we talking?
We're talking about moving beyond mechanical vibrations or crystal oscillations entirely. Atomic clocks tap into the fundamental, unchanging properties of atoms themselves. They represent the absolute pinnacle of timekeeping accuracy.
How do they achieve that? What's the principle?
Instead of a physical pendulum or a vibrating crystal, atomic clocks use the natural, constant vibration or resonance frequency of atoms. The international standard for defining the second, for instance, is based on atoms of the element cesium-133.
Cesium-133, how does that work?
Okay, simplifying a bit. Atomic clocks use microwave signals to excite these cesium atoms. They then precisely tune the frequency of those microwaves until they find the exact frequency that causes the maximum number of cesium atoms to change their energy state to make a specific, predictable quantum leap.
And that specific microwave frequency corresponds to the atom's natural, unchanging resonance.
Exactly. That specific resonance frequency is incredibly stable, incredibly consistent, defined by fundamental physics. And the international definition of 1 second is now formally based on this atomic behavior.
What is the definition?
1 second is defined as the time duration of precisely 9,192,631,770 cycles.
Whoa, say that again. 9 billion.
9,192,631,770 oscillations of the radiation, corresponding to the transition between two specific energy levels in a cesium-133 atom.
9 billion cycles to define 1 second. That number is just staggering. The precision is almost unfathomable.
It truly is remarkable. We're talking accuracy to within fractions of a billionth of a second per day. And this extreme precision isn't just an academic curiosity. It's absolutely essential for a vast array of modern technologies we rely on constantly.
Like what? Give us some examples of what atomic clock precision enables.
Well, the sources list critical applications. Think about guiding airplanes safely across continents. Their navigation systems require incredibly precise timing.
Okay, aviation. What else?
Syncing global financial markets. Stock trades happen instantaneously across different time zones. That depends entirely on atomic clocks providing a universal, perfectly synchronized timestamp for every transaction.
Right, to prevent discrepancies.
Right.
It's something we use every day.
GPS navigation, global positioning system. This technology fundamentally relies on atomic clocks.
How?
The network of satellites orbiting Earth that make GPS work each carry multiple, highly accurate atomic clocks on board. Your phone, or your car's GPS receiver, calculates your position by measuring the tiny differences in the time it takes to receive signals from several of these satellites.
And because radio waves travel at the speed of light,
Even a tiny timing error, a billionth of a second error, would translate into a significant error in calculating your position on the ground, maybe meters off. Atomic clock accuracy is what allows your GPS to pinpoint your location down to potentially a matter of centimeters.
wow. So this relentless pursuit of precision, from sundials watching shadows to counting atomic oscillations, has powered science, global coordination, the very tech that structures modern life.
It really has. But the sources pose a critical question here, one that feels particularly relevant today.
Which is?
As we gain this unprecedented ability to measure time with such incredible precision, do we actually live it more deeply or even better?
And that question leads us right into a contemporary human dilemma, doesn't it?
It really does. We live in an era where time, or at least its measurement, is just omnipresent. We carry devices in our pockets, our smartphones, that don't just display the time
They
constantly.
track everything, our steps, our heartbeats, schedule every minute with calendar alerts, measure our screen time, analyze our sleep. We're drowning in data about how we spend our time.
We have more tools than ever before, dedicated to monitoring, optimizing, organizing time. We seem to have achieved this incredible level of control over how time is measured and scheduled.
And yet,
The sources highlight this profound paradox. Despite all this precision and control, many of us feel more rushed, more pressed for time than ever before.
it absolutely feels like that. Like time is accelerating, constantly slipping through our fingers, even as we try to capture and measure every second.
It does. And this feeling of time being this precious, vanishing resource, it isn't entirely new perhaps, but it seems really exacerbated in our modern, hyper-scheduled, always-on world.
The sources quote the Roman philosopher Seneca on this.
Yes, Seneca observed this phenomenon long ago. He wrote, "It is not that we have a short time to live, but that we waste much of it." His words really resonate today, don't they?
They do, suggesting the issue might be less about the objective quantity of time we have and more about our perception and our use of it.
That's a powerful reframing. The ancient world, perhaps less driven by precise schedules, might have experienced time as more abundant, maybe, tied to slower natural rhythms. We, on the other hand, often view time as this scarce commodity.
Something to be managed, saved, spent wisely, or tragically lost or wasted.
Exactly. This modern anxiety about time passing too quickly, the feeling of being unable to keep up or make the most of it. It even has a name: chronophobia, the fear of time passing too fast.
Chronophobia, that's a real thing.
Apparently so. A real psychological phenomenon reflecting the pressure and unease many feel in our time-obsessed culture.
And in response to this feeling, this pressure, we see the rise of movements like mindfulness and slow living.
Yes, these movements can be seen as a direct counterpoint to that relentless emphasis on speed, efficiency, constant measurement. Their core message, as described in the sources, is really a call to shift our focus.
Ow!
To stop primarily counting time every minute, every second, and instead start consciously feeling it, experiencing the present moment more fully rather than constantly thinking about the next scheduled event or how quickly the clock is ticking.
It's about reconnecting with time on a deeper, more personal, maybe even physical level, rather than just an intellectual or organizational one.
The sources pose some really insightful questions to prompt that kind of reflection. Like, can you consciously try to breathe in sync with your own heartbeat? Feel that internal rhythm.
Or can you just sit in silence, without distractions, and notice how long a minute truly feels? Allow yourself to experience its duration fully, subjectively.
These aren't just abstract questions, they're invitations to experience time differently, to become aware of our internal clock, the subjective nature of time's passage, which can feel very different from the steady, relentless tick of an external objective clock.
It suggests that perhaps the real challenge, maybe the next revolution in our relationship with time, isn't about building even more precise devices to measure it.
But about transforming how we subjectively experience and value the time we have, shifting from measuring units to feeling moments.
Has all this precision given us more control over life, or maybe just made us more acutely, anxiously aware of its fleeting nature? It's definitely a lot to ponder.
It really is.
And that brings us towards the close of this deep dive. We've traveled such a long road, haven't we?
We really have. From tracing shadows on the ground with a simple gnomon,
To watching water drip in a clepsydra, calculating cycles with Babylonian base 60 math.
enduring the political manipulation of Roman calendars, coordinating life by the sound of monastic bells.
Living by the precise, often controlling beat of mechanical clocks.
And finally, arriving at the almost unimaginable accuracy of atomic oscillations that underpin our entire modern technological world.
It's a history that just shows humanity's incredible ingenuity, our perseverance in trying to grasp and structure this thing called time.
And as the sources highlight throughout this journey, the way we have measured and perceived time at different points in history has consistently served as a mirror, reflecting, as they say, who we are and what we value as a society at that time.
You can see it clearly. Early skywatchers valued survival, natural cycles. Egyptians valued divine order, agricultural security. Babylonians valued mathematical order, celestial harmony.
Romans valued political control, imperial administration. Medieval communities valued communal life, religious discipline. The industrial age valued efficiency, productivity.
And our modern age seems to value technological precision, optimization, speed.
So as the grains of sand fall through this conceptual hourglass of history we've explored together, we arrive at a final, really powerful thought presented in the sources, framed as the wisdom that the hourglass speaks.
And what is that thought?
It's this. Perhaps time isn't ultimately meant to be fully mastered or controlled or even just meticulously measured down to the nanosecond. Maybe ultimately it is meant to be felt.
To be felt, that's a profound shift in perspective.
It is. Time seen not just as an answer you wrote on a dial, but as a question. Time experienced not just as a rigid rule imposed from outside, but as a rhythm you feel internally and share communally.
So the next time you instinctively glance at your watch or your phone or your computer screen to check the hour, pause for just a moment. Don't just ask that automatic question, what time is it?
Instead, maybe ask yourself the deeper question the sources leave us with. How am I spending it?
A challenging and really thought-provoking reflection drawn directly from the source material you shared with us. A good place to end our dive.
A powerful reminder, maybe, to connect with the present moment. Breathe in, slow down, and perhaps just try to feel the flow of time.